রূপপুর পারমাণবিক বিদ্যুৎ কেন্দ্রে 521টি পদে নিয়োগ হচ্ছে, আর লক্ষাধিক প্রার্থী একই স্বপ্ন দেখছে। কিন্তু ভাইভা বোর্ডে বেশিরভাগ প্রার্থী শুধুমাত্র বয়লারের এই 6টি প্রশ্নে আটকে যায়। আজ আমি আপনাকে সেই প্রশ্নগুলো এবং পরীক্ষা করা ঠিক কি উত্তর শুনতে চান তা বলে দেব। শেষ পর্যন্ত থাকুন, চাকরিটা আপনারই হবে। স্টিম পাইপলাইনে ওয়াটার হ্যামার কি? ওয়াটার হ্যামার হল দ্রুতগতির স্টিম পাইপলাইনের ভেতরে জমে থাকা পানির সাথে আঘাত করলে সৃষ্ট আকস্মিক চাপ। এতে জোরে শব্দ হয় এবং ভালভ, বেন্ড, সাপোর্ট, জয়েন্ট ও অন্যান্য যন্ত্রপাতি ক্ষতিগ্রস্ত হতে পারে। সাধারণত খারাপ ড্রেনেজ, ত্রুটিপূর্ণ স্টিম ট্র্যাপ, ভুল পাইপ ডিজাইন বা হঠাৎ ভালভ চালুর কারণে এটি ঘটে। ইন্সপেক্টররা এই প্রশ্নের মাধ্যমে বাস্তব স্টিম সিস্টেম জ্ঞান ও সমস্যা সমাধানের দক্ষতা যাচাই করেন। সঠিক ড্রেনেজ ও স্টিম ট্র্যাপ রক্ষণাবেক্ষণ ওয়াটার হ্যামার প্রতিরোধে সাহায্য করে।
Please like, share and comment the video.
স্টিম সিস্টেমে কনডেনসেট রিকভারি কেন গুরুত্বপূর্ণ? কনডেনসেট রিকভারি শক্তি সাশ্রয়ে গুরুত্বপূর্ণ ভূমিকা পালন করে, কারণ গরম কনডেন্সড পানি আবার বয়লারের ফিড সিস্টেমে ফেরত পাঠানো হয়। কনডেনসেটে আগে থেকেই তাপ থাকে, তাই এটিকে পুনরায় স্টিমে রূপান্তর করতে কম জ্বালানি লাগে। এছাড়া কনডেনসেট সাধারণত পরিষ্কার হওয়ায় ওয়াটার ট্রিটমেন্ট খরচও কমে যায়। ইন্সপেক্টররা এই প্রশ্নের মাধ্যমে শক্তি সাশ্রয় ও স্টিম সিস্টেম সম্পর্কে ধারণা যাচাই করেন। সঠিক কনডেনসেট রিকভারি বয়লারের কার্যক্ষমতা বাড়ায়, পানি সংরক্ষণ করে এবং পরিচালন ব্যয় কমায়।
Please like, share and comment the video.
বয়লারে হাইড্রোস্ট্যাটিক টেস্ট কেন করা হয়? হাইড্রোস্ট্যাটিক টেস্ট করা হয় বয়লারের শেল, টিউব ও প্রেসার পার্টগুলোর শক্তি ও লিক প্রতিরোধ ক্ষমতা পরীক্ষা করার জন্য। এই পরীক্ষায় বয়লার সম্পূর্ণ পানি দিয়ে ভরা হয় এবং পাম্পের সাহায্যে স্বাভাবিক অপারেটিং প্রেসারের চেয়ে বেশি চাপ প্রয়োগ করা হয়। পানি ব্যবহার করা হয় কারণ এটি প্রায় অসংকুচিত এবং কম্প্রেসড এয়ারের তুলনায় অনেক নিরাপদ। ইন্সপেক্টররা এই প্রশ্নের মাধ্যমে নিরাপত্তা মান ও পরিদর্শন পদ্ধতি সম্পর্কে জ্ঞান যাচাই করেন। এই টেস্ট দুর্বল জয়েন্ট, ফাটল, লিকেজ ও কাঠামোগত ত্রুটি শনাক্ত করতে সাহায্য করে।
Please like, share and comment the video.
বয়লার রুমে সঠিক ভেন্টিলেশন কেন গুরুত্বপূর্ণ? বয়লার রুমে সঠিক ভেন্টিলেশন নিরাপদ দহন ও কর্মীদের নিরাপত্তার জন্য অত্যন্ত গুরুত্বপূর্ণ। সম্পূর্ণ দহনের জন্য বয়লারে পর্যাপ্ত তাজা বাতাস প্রয়োজন। ভেন্টিলেশন খারাপ হলে অক্সিজেনের ঘাটতি দেখা দেয়, ফলে অপূর্ণ দহন, ধোঁয়া, স্যুট এবং বিপজ্জনক কার্বন মনোক্সাইড জমা হতে পারে। অতিরিক্ত তাপ যন্ত্রপাতির কার্যক্ষমতাও কমিয়ে দেয় এবং অস্বাস্থ্যকর কর্মপরিবেশ তৈরি করে। ইন্সপেক্টররা এই প্রশ্ন করেন কারণ ভেন্টিলেশন সরাসরি নিরাপত্তা ও দক্ষতার সাথে সম্পর্কিত। ভালো ভেন্টিলেশন দহন মান উন্নত করে, অপারেটরদের সুরক্ষা দেয় এবং নিরাপদ কর্মপরিবেশ নিশ্চিত করে।
Please like, share and comment the video.
বয়লার প্রাইমিং কি এবং এটি কেন বিপজ্জনক? বয়লার প্রাইমিং হল এমন অবস্থা যখন স্টিমের সাথে পানির ফোঁটাও বের হয়ে যায়। এটি সাধারণত অতিরিক্ত পানির স্তর, হঠাৎ ফুটন বা অতিরিক্ত স্টিম চাহিদার কারণে ঘটে। ভেজা স্টিমের মান কমিয়ে দেয় এবং স্টিম টারবাইন, ভালভ, পাইপলাইন ও অন্যান্য যন্ত্রপাতির ক্ষতি করতে পারে। প্রাইমিংয়ের কারণে স্টিম লাইনে ওয়াটার হ্যামারও তৈরি হতে পারে, যা পাইপলাইনের মারাত্মক ক্ষতি করে। ইন্সপেক্টররা এই প্রশ্নের মাধ্যমে স্টিমের গুণগত মান ও বয়লার পরিচালনা সম্পর্কে জ্ঞান যাচাই করেন। সঠিক পানির স্তর নিয়ন্ত্রণ, ভালো ডিজাইন ও সঠিক ওয়াটার ট্রিটমেন্ট প্রাইমিং প্রতিরোধে সাহায্য করে।
Please like, share and comment the video.
বয়লারে দহনের জন্য অতিরিক্ত বাতাস কেন প্রয়োজন? তাত্ত্বিকভাবে নির্ধারিত সঠিক পরিমাণ বাতাস দিয়ে সম্পূর্ণ দহন বাস্তবে সম্ভব নয়, তাই অতিরিক্ত বাতাস প্রয়োজন হয়। এই অতিরিক্ত বাতাস জ্বালানির সম্পূর্ণ দহন নিশ্চিত করে এবং কার্বন মনোক্সাইড, ধোঁয়া ও স্যুট তৈরি হওয়া প্রতিরোধ করে। তবে অতিরিক্ত বেশি বাতাসও ক্ষতিকর, কারণ এটি চিমনির মাধ্যমে তাপ বাইরে নিয়ে যায় এবং বয়লারের কার্যক্ষমতা কমায়। ইন্সপেক্টররা এই প্রশ্নের মাধ্যমে দহন ভারসাম্য সম্পর্কে ধারণা যাচাই করেন। দক্ষ অপারেটররা সঠিক এয়ার ফুয়েল অনুপাত বজায় রাখেন যাতে নিরাপদ ও কার্যকর দহন নিশ্চিত হয়। সঠিক বার্নার টিউনিং ও নিয়মিত কম্বাসশন অ্যানালাইসিস জ্বালানি সাশ্রয় ও স্টিম উৎপাদন উন্নত করে।
প্লিজ লাইক, শেয়ার অ্যান্ড কমেন্ট দ্য ভিডিও।
বয়লারে ফিড ওয়াটার ট্রিটমেন্ট কেন গুরুত্বপূর্ণ? ফিড ওয়াটার ট্রিটমেন্ট গুরুত্বপূর্ণ কারণ অপরিশোধিত পানিতে থাকা খনিজ, অক্সিজেন ও অশুদ্ধি বয়লারের অভ্যন্তরে ক্ষতি করতে পারে। কঠিন পানি স্কেল তৈরি করে এবং দ্রবীভূত অক্সিজেন টিউব ও ড্রামের ভিতরে ক্ষয় সৃষ্টি করে। এই দুই অবস্থায় তাপ পরিবহন কমিয়ে দেয় এবং জ্বালানির ব্যবহার বাড়ায়। অতিরিক্ত ক্ষয়ের ফলে ধাতব অংশ দুর্বল হয়ে লিকেজও হতে পারে। পানি বয়লারে প্রবেশের আগে ক্ষতিকর উপাদান অপসারণ করাই ওয়াটার ট্রিটমেন্টের মূল উদ্দেশ্য। ইন্সপেক্টররা এই প্রশ্নের মাধ্যমে পানির মান ও বয়লার নিরাপত্তার সম্পর্কে অপারেটরের ধারণা যাচাই করেন। ভালো ওয়াটার ট্রিটমেন্ট স্টিমের মান উন্নত করে, রক্ষণাবেক্ষণ সমস্যা কমায় এবং যন্ত্রপাতির আজু বাড়ায়।
প্লিজ লাইক, শেয়ার অ্যান্ড কমেন্ট দ্য ভিডিও।
প্রতিদিন বয়লার ব্লোডাউন করা কেন প্রয়োজন? বয়লার ব্লোডাউন করা হয় বয়লারের পানির ভেতর জমে থাকা দ্রবীভূত লবণ, কাদা, ময়লা ও অন্যান্য অশুদ্ধি বের করে দেওয়ার জন্য। স্টিম তৈরি হওয়ার সময় বিশুদ্ধ বাষ্প বেরিয়ে যায়, কিন্তু অশুদ্ধিগুলো বয়লারের ভেতরে থেকে যায়। সময়ের সাথে সাথে এসব অশুদ্ধির ঘনত্ব বেড়ে টিউবের উপর স্কেল তৈরি করে। স্কেল তাপ পরিবহন কমিয়ে দেয় এবং অতিরিক্ত তাপ, জ্বালানির অপচয় ও টিউব ক্ষতির কারণ হয়। দৈনিক ব্লোডাউন সঠিক টিডিএস থিডস লেভেল বজায় রাখতে সাহায্য করে এবং বয়লারের কার্যক্ষমতা বাড়ায়। অনেক অপারেটর প্রক্রিয়াটি জানলেও এর প্রকৃত কারণ জানে না, তাই ইন্সপেক্টররা এই প্রশ্ন করেন। সঠিক ব্লোডাউন পদ্ধতি বয়লারের আজু বৃদ্ধি করে এবং নিরাপদ ও কার্যকর পরিচালনা নিশ্চিত করে।
প্লিজ লাইক, শেয়ার অ্যান্ড কমেন্ট দ্য ভিডিও।
বয়লারের ফার্নেসে ফ্লেম ফেলিউর কেন বিপজ্জনক? ফ্লেম ফেলিউর বিপজ্জনক কারণ সঠিক দহন ছাড়াই জ্বালানি ফার্নেসে প্রবেশ করতে থাকে। অপূর্ণ দহন হওয়া জ্বালানি ফার্নেসের ভিতরে জমে বাতাসের সাথে মিশে বিস্ফোরক পরিবেশ তৈরি করে। হঠাৎ ইগনিশন হলে কয়েক সেকেন্ডের মধ্যেই ফার্নেস বিস্ফোরণ ঘটতে পারে। এজন্য ফ্লেম ফেলিউর ঘটলে অপারেটরকে সঙ্গে সঙ্গে জ্বালানি সরবরাহ বন্ধ করতে হয়। আধুনিক বয়লারে ফ্লেম স্ক্যানার ও সেফটি ইন্টারলক ব্যবহৃত হয় যা স্বয়ংক্রিয়ভাবে ফ্লেম না থাকলে তা শনাক্ত করে। ইন্সপেক্টররা এই প্রশ্নের মাধ্যমে জরুরি পরিস্থিতিতে সঠিক পদক্ষেপ নেওয়ার জ্ঞান যাচাই করেন। প্রশিক্ষিত অপারেটরকে বুঝতে হবে যে দ্রুত ব্যবস্থা নেওয়া বড় দুর্ঘটনা, যন্ত্রপাতির ক্ষতি ও উৎপাদন বন্ধ হওয়া প্রতিরোধ করতে পারে।
প্লিজ লাইক, শেয়ার অ্যান্ড কমেন্ট দ্য ভিডিও।
বয়লারের সবচেয়ে বিপজ্জনক অবস্থা কি? বয়লারের সবচেয়ে বিপজ্জনক অবস্থা হল পানির স্তর কমে যাওয়া। যখন পানির লেভেল নিরাপদ সীমার নিচে নেমে যায়, তখন বয়লারের টিউবগুলো সরাসরি ফার্নেসের তাপের সংস্পর্শে আসে। পানি দিয়ে শীতল না হওয়ায় টিউবের ধাতব তাপমাত্রা দ্রুত বেড়ে যায়, ফলে টিউব দুর্বল হয়ে ফেটে যেতে পারে। এতে ভয়াবহ বয়লার বিস্ফোরণ ঘটতে পারে। অনেক অপারেটর শুধু প্রেসারের দিকে গুরুত্ব দেয়, কিন্তু ইন্সপেক্টররা সাধারণত সঠিক পানির স্তর বজায় রাখার গুরুত্ব বোঝে কিনা তা যাচাই করেন। গেজ গ্লাস, অ্যালার্ম এবং লো ওয়াটার কাট অফ ডিভাইস নিয়মিত পর্যবেক্ষণ করা নিরাপদ পরিচালনা ও দুর্ঘটনা প্রতিরোধের জন্য অত্যন্ত গুরুত্বপূর্ণ।
প্লিজ লাইক, শেয়ার অ্যান্ড কমেন্ট দ্য ভিডিও।
বয়লার খুব দ্রুত চালু করা উচিত নয় কেন? বয়লার খুব দ্রুত চালু করলে বয়লারের শেল ও টিউবের ভিতরে হঠাৎ তাপমাত্রার পরিবর্তন ঘটে। দ্রুত গরম হওয়ার ফলে ধাতব অংশ অসমভাবে প্রসারিত হয়, যাকে থার্মাল স্ট্রেস বলা হয়। এই চাপ টিউব ফেটে যাওয়া, রিফ্র্যাক্টরি ক্ষতিগ্রস্ত হওয়া, ওয়েল্ডিং জয়েন্ট দুর্বল হয়ে যাওয়া এবং বয়লারের আজু কমে যাওয়ার কারণ হতে পারে। ইন্সপেক্টররা এই প্রশ্ন করেন কারণ অনেক অপারেটর শুধু দ্রুত উৎপাদনের দিকে গুরুত্ব দেয়, কিন্তু যন্ত্রপাতি সুরক্ষার গুরুত্ব বোঝে না। সঠিক স্টার্টআপ পদ্ধতিতে ধীরে ধীরে তাপ ও চাপ বাড়ানো হয় যাতে সব অংশ সমানভাবে প্রসারিত হতে পারে। ধীরগতিতে স্টার্টআপ নিরাপত্তা বাড়ায়, রক্ষণাবেক্ষণ খরচ কমায় এবং দীর্ঘমেয়াদী কাঠামোগত ক্ষতি প্রতিরোধ করে।
Please like, share and comment the video.
বয়লার জরুরি অবস্থায় প্রথম অগ্রাধিকার কি হওয়া উচিত? বয়লার জরুরি অবস্থায় প্রথম অগ্রাধিকার হল মানব জীবন রক্ষা করা এবং আরও বিপদ প্রতিরোধ করা। অপারেটরকে সঙ্গে সঙ্গে জরুরি শাটডাউন প্রক্রিয়া অনুসরণ করতে হবে, জ্বালানি সরবরাহ বন্ধ করতে হবে এবং প্রয়োজনে অ্যালার্ম চালু করতে হবে। বিস্ফোরণ, আগুন, স্টিম লিকেজ বা বিষাক্ত গ্যাস নির্গমনের ঝুঁকি থাকলে দ্রুত এলাকা খালি করতে হবে। কর্মীদের নিরাপত্তা নিশ্চিত করার পর প্রেসার, তাপমাত্রা ও পানির স্তর সতর্কতার সাথে মূল্যায়ন করতে হবে। ইন্সপেক্টররা এই প্রশ্নের মাধ্যমে জরুরি পরিস্থিতি মোকাবিলা ও নিরাপত্তা সচেতনতা যাচাই করেন। দ্রুত সিদ্ধান্ত নেওয়া, সঠিক যোগাযোগ ও স্ট্যান্ডার্ড অপারেটিং পদ্ধতি অনুসরণ করা দুর্ঘটনা, ক্ষয়ক্ষতি ও উৎপাদন ক্ষতি কমাতে অত্যন্ত গুরুত্বপূর্ণ।
Please like, share and comment the video.
বয়লারে স্টিম প্রেসার সতর্কতার সাথে নিয়ন্ত্রণ করা কেন জরুরি? স্টিম প্রেসার সতর্কতার সাথে নিয়ন্ত্রণ করা জরুরি কারণ অতিরিক্ত বা কম দুই ধরনের প্রেসারই অপারেশনাল সমস্যা সৃষ্টি করে। অতিরিক্ত প্রেসার বয়লারের যন্ত্রাংশে অতিরিক্ত চাপ সৃষ্টি করে এবং লিকেজ, যন্ত্রপাতি নষ্ট হওয়া বা বিস্ফোরণের ঝুঁকি বাড়ায়। অন্যদিকে কম প্রেসার স্টিম সরবরাহে সমস্যা সৃষ্টি করে এবং উৎপাদন দক্ষতা কমিয়ে দেয়। প্রেসার কন্ট্রোল সিস্টেম জ্বালানি সরবরাহ ও স্টিম উৎপাদন নিয়ন্ত্রণের মাধ্যমে স্থিতিশীল অপারেশন বজায় রাখে। ইন্সপেক্টররা এই প্রশ্নের মাধ্যমে বয়লারের ব্যালেন্স ও কন্ট্রোল সিস্টেম সম্পর্কে জ্ঞান যাচাই করেন। সঠিক প্রেসার নিয়ন্ত্রণ কার্যক্ষমতা বাড়ায়, যন্ত্রপাতি রক্ষা করে এবং নিরাপদ পরিচালনা নিশ্চিত করে।
Please like, share and comment the video.
বয়লার চালুর আগে ফার্নেস পার্জিং কেন প্রয়োজন? ফার্নেস পার্জিং হল ইগনিশনের আগে ফার্নেসের ভেতরে থাকা অপূর্ণ দহন হওয়া গ্যাস বের করে দেওয়ার প্রক্রিয়া। ফ্যানের মাধ্যমে তাজা বাতাস প্রবাহিত করে ভেতরের দাহ্য গ্যাস অপসারণ করা হয়। যদি পার্জিং না করা হয় এবং ভেতরে গ্যাস থাকা অবস্থায় ইগনিশন শুরু হয়, তাহলে ভয়াবহ ফার্নেস বিস্ফোরণ ঘটতে পারে। অনেক দুর্ঘটনা ভুল স্টার্টআপ পদ্ধতির কারণে ঘটে। তাই ইন্সপেক্টররা এই প্রশ্নটি করেন। পার্জিংয়ের সময় বয়লারের ডিজাইন ও নিরাপত্তা মান অনুযায়ী নির্ধারিত হয়। সঠিক পার্জিং নিরাপদ ইগনিশন নিশ্চিত করে, যন্ত্রপাতি রক্ষা করে এবং দুর্ঘটনা প্রতিরোধ করে।
Please like, share and comment the video.
গেজ গ্লাস নিয়মিত পরীক্ষা করা কেন জরুরি? গেজ গ্লাস বয়লারের ড্রামের ভেতরের প্রকৃত পানির স্তর নির্দেশ করে। যদি গেজ গ্লাস ব্লক হয়ে যায়, ময়লা জমে বা ক্ষতিগ্রস্ত হয়, তাহলে এটি ভুল রিডিং দেখাতে পারে। ভুল পানির স্তর দেখানো অত্যন্ত বিপজ্জনক, কারণ অপারেটর মনে করতে পারেন পানির স্তর স্বাভাবিক আছে, অথচ বয়লার প্রায় শুকিয়ে গেছে। এতে অতিরিক্ত তাপ ও টিউব ফেইলিউর হতে পারে। ইন্সপেক্টররা এই প্রশ্নের মাধ্যমে বাস্তব অপারেশন সম্পর্কে সচেতনতা যাচাই করেন। অপারেটরদের নিয়মিত গেজ গ্লাস ব্লো থ্রু ও পরিষ্কার করতে হবে যেন সঠিক রিডিং পাওয়া যায়। পরিষ্কার ও কার্যকর গেজ গ্লাস বজায় রাখা বয়লার নিরাপত্তার একটি অত্যন্ত গুরুত্বপূর্ণ অংশ।
Please like, share and comment the video.
সুট জমার কারণে বয়লারের কার্যক্ষমতা কেন কমে যায়? সুট হল অপূর্ণ জ্বালানি দহনের ফলে তৈরি হওয়া কালো কার্বনের আস্তরণ। যখন বয়লারের টিউবের উপর সুট জমে, তখন এটি একটি নিরোধক স্তর তৈরি করে যা গরম ফ্লু গ্যাস থেকে পানিতে তাপ স্থানান্তর বাধাগ্রস্ত করে। ফলে একই পরিমাণ স্টিম উৎপাদনের জন্য বেশি জ্বালানি প্রয়োজন হয়, যা বয়লারের কার্যক্ষমতা কমায় এবং পরিচালন ব্যয় বাড়ায়। অতিরিক্ত সুট ফ্লু গ্যাসের তাপমাত্রা বাড়ায় এবং অগ্নিকাণ্ডের ঝুঁকিও সৃষ্টি করতে পারে। ইন্সপেক্টররা এই প্রশ্নের মাধ্যমে দহন প্রক্রিয়া ও রক্ষণাবেক্ষণ সম্পর্কে জ্ঞান যাচাই করেন। নিয়মিত সুট ব্লোয়িং, সঠিক বার্নার সমন্বয় এবং উপযুক্ত এয়ারফুয়েল অনুপাত বজায় রাখলে কার্যক্ষমতা ভালো থাকে।
Please like, share and comment the video.
বারবার বয়লার টিউব ফেলিউরের কারণ কি? বারবার বয়লার টিউব ফেলিউর সাধারণত খারাপ ওয়াটার ট্রিটমেন্ট, অতিরিক্ত তাপ, ক্ষয়, স্কেল জমা, থার্মাল স্ট্রেস বা ভুল পরিচালনার কারণে হয়। স্কেল জমে গেলে তাপ পরিবহন কমে যায় এবং টিউবের ধাতব তাপমাত্রা বেড়ে যায়, ফলে টিউব দুর্বল হয়ে পড়ে। ক্ষয় টিউবের পৃষ্ঠ আক্রমণ করে এবং ধীরে ধীরে দেয়ালের পুরুত্ব কমিয়ে দেয়। হঠাৎ তাপমাত্রা পরিবর্তনের কারণে থার্মাল স্ট্রেস তৈরি হয় যা টিউব ক্ষতিগ্রস্ত করে। ইন্সপেক্টররা এই প্রশ্নের মাধ্যমে সমস্যা শনাক্ত ও রক্ষণাবেক্ষণ সম্পর্কে জ্ঞান যাচাই করেন। একজন দক্ষ অপারেটরকে বারবার টিউব পরিবর্তন না করে মূল কারণ খুঁজে বের করতে হবে। সঠিক ওয়াটার কেমিস্ট্রি, নিয়মিত পরিদর্শন ও প্রতিরোধমূলক রক্ষণাবেক্ষণ টিউব ফেলিউর কমাতে সাহায্য করে।
Please like, share and comment the video.
সেফটি ভালভ সঠিকভাবে কাজ না করলে কি হয়? সেফটি ভালভ বয়লারের সবচেয়ে গুরুত্বপূর্ণ নিরাপত্তা ডিভাইসগুলোর একটি। এর প্রধান কাজ হল প্রেসার নিরাপদ সীমা অতিক্রম করলে অতিরিক্ত বাষ্প স্বয়ংক্রিয়ভাবে বের করে দেওয়া। যদি সেফটি ভালভ কাজ না করে, তাহলে বয়লারের ভেতরে চাপ ক্রমাগত বাড়তে থাকে। অতিরিক্ত চাপ বয়লারের গঠন দুর্বল করে এবং শেষ পর্যন্ত ভয়াবহ বিস্ফোরণ ঘটাতে পারে। ইন্সপেক্টররা প্রায়ই এই প্রশ্ন করেন কারণ অপারেটরদের বুঝতে হবে যে সেফটি ভালভ মানব জীবন ও যন্ত্রপাতি দুটোই রক্ষা করে। নিয়মিত টেস্টিং, ক্যালিব্রেশন ও রক্ষণাবেক্ষণ অত্যন্ত জরুরি। সঠিকভাবে কাজ করা সেফটি ভালভ দুর্ঘটনা ও ঝুঁকি কমায় এবং নিরাপত্তা বিধিমালা মেনে চলা নিশ্চিত করে।
Please like, share and comment the video.
Why is boiler drum level difficult to control at high load? Answer. Boiler drum level becomes difficult to control at high load because steam demand changes rapidly. When steam demand suddenly increases, bubbles form quickly inside the drum and temporarily raise the water level, known as the swell effect. When demand decreases, the water level may suddenly drop, called the shrink effect. Inspectors ask this question to test understanding of boiler dynamics and automatic control systems. Operators must carefully monitor drum level during load changes to avoid low water or carryover conditions. Proper feed water control systems and operator attention are essential for maintaining safe and stable boiler operation under varying industrial loads. Why is boiler maintenance important even when the boiler runs normally? Answer. Boilers may appear to operate normally while hidden problems develop internally over time. Scale buildup, corrosion, leakage, worn components, and safety device failures can gradually reduce efficiency and increase accident risk. Preventive maintenance identifies these problems before they become serious failures. Inspectors ask this question to test long-term operational thinking and maintenance awareness. Regular inspection, cleaning, lubrication, calibration, and testing improve equipment reliability and reduce emergency breakdowns. Proper maintenance also extends boiler life, improves steam production efficiency, lowers fuel consumption, and ensures compliance with industrial safety regulations. A well-maintained boiler always operates more safely and efficiently than a neglected one. Why should boiler alarms never be ignored? Answer. Boiler alarms provide early warning signals about unsafe operating conditions such as low water level, high pressure, flame failure, high temperature, or equipment malfunction. Ignoring alarms can allow minor problems to develop into major accidents, equipment damage, or dangerous explosions. Inspectors ask this question because operator response during abnormal conditions is extremely important for plant safety. Operators should immediately investigate every alarm, instead of resetting it without checking the root cause. Proper alarm management improves operational safety, prevents costly downtime, protects workers, and ensures reliable boiler operation. A responsible operator treats every alarm as an important safety warning signal. Why is feed water temperature important in boilers? Feed water temperature affects boiler efficiency and equipment protection. Warm feed water requires less fuel to convert into steam compared to cold water. Higher feed water temperature also reduces thermal stress on boiler components because sudden temperature differences are minimized. Inspectors ask this question to evaluate understanding of heat recovery and energy efficiency concepts. Economizers and condensate recovery systems are commonly used to increase feed water temperature before entering the boiler. Maintaining proper feed water temperature improves combustion efficiency, reduces fuel costs, protects pressure, parts from stress damage, and increases the overall performance of industrial steam generation systems significantly. Why is boiler insulation necessary? Answer: boiler insulation minimizes heat loss from hot surfaces such as steam pipes, drums, valves, and furnace walls. Without insulation, valuable heat escapes into the atmosphere, increasing fuel consumption and reducing system efficiency. Hot exposed surfaces may also create burn hazards for workers inside the boiler plant. Inspectors ask this question to test energy saving and safety awareness. Good insulation improves thermal efficiency, lowers operating costs, maintains stable steam temperature, and improves workplace safety. Operators should regularly inspect insulation for damage, moisture, or missing sections. Proper insulation is a simple but highly effective method for improving industrial boiler system performance and energy conservation. Why is proper boiler shutdown procedure important? Answer: proper boiler shutdown prevents thermal shock, equipment damage, and unsafe operating conditions. If cooling occurs too quickly, metal parts contract unevenly and may crack or warp. Incorrect shutdown may also leave pressure trapped inside the system or create unsafe maintenance conditions. Inspectors ask this question because many accidents occur during startup and shutdown operations rather than normal running conditions. Operators should reduce load gradually, stop fuel supply safely, maintain proper water level, and allow controlled cooling before inspection or maintenance. Following correct shutdown procedures protects equipment, improves operational safety, reduces repair costs, and extends the overall life of the boiler. Why are boiler refractory materials important? Answer: refractory materials protect the boiler furnace walls and reduce heat loss from high-temperature combustion gases. These heat-resistant materials help maintain furnace temperature, improve combustion efficiency, and protect metal structures from direct flame exposure. Damaged refractory increases fuel consumption, creates hotspots, and may overheat surrounding equipment. Inspectors ask this question to check understanding of boiler thermal protection systems. Operators should inspect refractory conditions regularly for cracks, erosion, or loose sections. Good refractory maintenance improves boiler efficiency, enhances safety, reduces operational costs, and extends the service life of furnace components operating under extreme industrial temperatures and combustion conditions. What is the purpose of a deaerator in a boiler system? Answer: a deaerator removes dissolved oxygen and other unwanted gases from boiler feed water before it enters the boiler. Feed water is heated inside the deaerator, causing dissolved gases to separate and escape safely. Removing oxygen is extremely important because oxygen causes corrosion inside boiler tubes, drums, and pipelines. Inspectors ask this question because many operators know the equipment name but not its real purpose. A properly functioning deaerator protects the boiler system from corrosion damage, improves water quality, reduces maintenance costs, and increases overall equipment reliability. It is one of the most important components in modern steam plants. Why is burner adjustment important in a boiler? Answer. Proper burner adjustment ensures complete and efficient fuel combustion inside the furnace. Incorrect burner settings may create smoke, soot, flame instability, fuel wastage, and dangerous carbon monoxide formation. Poor combustion also increases emissions and reduces steam generation efficiency. Inspectors ask this question to evaluate practical combustion knowledge. Operators must monitor flame color, air-fuel ratio, furnace pressure, and exhaust gas condition regularly. A. Well-adjusted burner produces stable flame, lower fuel consumption, cleaner combustion, and safe boiler operation. Regular burner inspection and tuning are essential for maintaining maximum efficiency and minimizing environmental pollution in industrial boiler plants and power facilities. Why is oxygen dangerous inside boiler water? Answer. Dissolved oxygen inside boiler water causes serious corrosion of boiler tubes, drums, and pipelines. Oxygen reacts chemically with metal surfaces and gradually creates rust, pitting, and thinning of pressure parts. Over time, corrosion weakens the boiler structure and may cause dangerous leakage or tube failure. Inspectors often ask this question because water chemistry is a critical part of boiler safety. Deaerators and chemical oxygen scavengers are commonly used to remove oxygen from feed water before it enters the boiler. Proper oxygen control extends equipment life, improves reliability, reduces maintenance costs, and prevents unexpected shutdowns in industrial steam systems. Why should boiler load increase gradually instead of suddenly? Answer. Boiler load should increase gradually because sudden steam demand creates rapid pressure and temperature fluctuations inside the boiler. Quick load changes may disturb water circulation, reduce steam quality, and create thermal stress on boiler components. In extreme situations, sudden load increase can even cause priming or carryover problems. Inspectors ask this question to test operational discipline and understanding of boiler stability. A trained operator always raises load slowly while monitoring pressure, water level, combustion condition, and feed water supply. Controlled load variation improves efficiency, protects boiler parts, reduces operational stress, and ensures safe long-term industrial boiler performance. Why should steam traps be maintained properly? Answer. Steam traps remove condensate and unwanted air from steam lines while preventing steam loss. If a steam trap fails open, valuable steam escapes continuously, wasting energy and increasing fuel costs. If it fails closed, condensate accumulates in pipelines and equipment, causing water hammer, corrosion, and poor heating performance. Inspectors ask this question to evaluate steam distribution system knowledge. Regular inspection and maintenance of steam traps improve energy efficiency, protect equipment, and ensure smooth steam flow throughout the plant. A properly maintained steam trap system reduces operational losses and improves the overall reliability of industrial steam systems significantly. Why are boiler safety interlocks important? Answer. Boiler safety interlocks automatically stop unsafe operation when abnormal conditions occur. They monitor parameters such as low water level, high pressure, flame failure, fuel supply problems, and fan failure. If any unsafe condition appears, the interlock system shuts down the burner or boiler immediately to prevent accidents. Inspectors ask this question because safety interlocks are critical for modern boiler protection systems. Operators must never bypass or ignore interlock alarms. Properly functioning interlocks reduce human error, improve operational safety, protect equipment from severe damage, and help prevent dangerous boiler explosions. Regular testing of safety systems is essential for reliable plant operation. What is water hammer in steam pipelines? Answer. Water hammer is a sudden pressure shock caused by fast-moving steam hitting accumulated water inside pipelines. This impact creates loud banging sounds and may damage valves, bends, supports, joints, and steam equipment. Water hammer commonly occurs due to poor drainage, faulty steam traps, improper piping, design, or sudden valve operation. Inspectors ask this question because it tests practical steam system knowledge and troubleshooting skills. Proper steam trap, maintenance, correct pipe slope, effective drainage systems, and gradual valve operation help prevent water hammer. Ignoring water hammer problems may lead to serious pipeline failure, operational downtime, and expensive maintenance issues. Why is condensate recovery important in steam systems? Answer. Condensate recovery improves energy efficiency by returning hot condensed water back to the boiler feed system. Since condensate already contains heat, less fuel is required to convert it back into steam. Recovering condensate also reduces water treatment costs because condensate is usually cleaner than fresh makeup. Water. Inspectors ask this question to test energy-saving knowledge and steam system understanding. A proper condensate recovery system improves boiler efficiency, conserves water, lowers operating expenses, and reduces thermal shock inside the boiler. Efficient industries always maximize condensate return to improve overall plant performance and reduce unnecessary energy losses in steam operations. Why is a boiler hydrostatic test performed? Answer. A hydrostatic test is performed to check the strength and leak tightness of the boiler shell, tubes, and pressure parts. During the test, the boiler is filled completely with water and pressure is increased above normal operating pressure using a pump. Water is used because it is nearly incompressible and safer than compressed air during testing. Inspectors ask this question to evaluate understanding of boiler inspection procedures and safety standards. Hydrostatic testing helps identify weak joints, cracks, leaks, and structural defects before operation. Regular testing ensures the boiler can safely withstand pressure during normal industrial service conditions without failure risks. Why is boiler ventilation important inside the boiler room? Answer. Proper boiler room ventilation is essential for safe combustion and worker safety. Boilers require sufficient fresh air for complete fuel combustion. Poor ventilation can reduce oxygen supply, causing incomplete combustion, soot formation, smoke, and dangerous carbon monoxide accumulation. Excessive heat inside the boiler room may also affect equipment performance and create unsafe working conditions. Inspectors ask this question because ventilation directly affects safety and efficiency. A well-ventilated boiler room improves combustion quality, protects operators, prevents overheating of electrical equipment, and ensures compliance with industrial safety standards. Proper airflow management is a critical part of safe boiler plant operation and maintenance. What is boiler priming and why is it dangerous? Answer. Boiler priming occurs when water droplets carry over with steam due to high water level, sudden boiling, or excessive steam demand. Wet steam reduces steam quality and may damage steam turbines, valves, pipelines, and process equipment. Priming also creates water hammer conditions inside steam lines, which can seriously damage piping systems. Inspectors ask this question because it tests knowledge of steam quality and boiler operation. Proper water level control, good boiler design, correct steam demand management, and proper water treatment help prevent priming. Dry, high-quality steam is always necessary for efficient and safe industrial operation in steam systems. Why is excess air required for combustion in boilers? Answer. Excess air is required because perfect combustion is practically impossible with exact theoretical air supply. Additional air ensures complete burning of fuel and prevents formation of carbon monoxide, soot, and smoke. However, too much excess air is also harmful because it carries away heat through the chimney, reducing boiler efficiency. Inspectors ask this question to check understanding of combustion balance. Skilled operators maintain the correct air-fuel ratio for efficient and safe combustion. Proper burner tuning, oxygen monitoring, and regular combustion analysis help optimize fuel usage, reduce emissions, improve steam production, and ensure stable boiler operation under varying load conditions. Why is boiler efficiency reduced by soot formation? Answer: soot is a black carbon deposit formed due to incomplete fuel combustion. When soot accumulates on boiler tubes, it acts as an insulating layer that blocks heat transfer from hot flue gases to water. As a result, more fuel is required to produce the same amount of steam, reducing boiler efficiency and increasing operating costs. Excessive soot also increases flue gas temperature and may create fire hazards inside the boiler. Inspectors ask this question to test combustion knowledge and maintenance awareness. Regular soot blowing, proper burner adjustment, and correct air-fuel ratio help maintain clean heat transfer surfaces and efficient boiler performance. Why should a boiler never be started too quickly? Answer: starting a boiler too quickly creates sudden temperature changes inside the boiler shell and tubes. Rapid heating causes uneven metal expansion, known as thermal stress. This stress may crack tubes, damage refractory materials, weaken welded joints, and shorten boiler life. Inspectors ask this question because many operators focus only on production speed instead of equipment protection. A proper startup procedure allows gradual heating and pressure buildup, ensuring all components expand evenly. Slow startup improves safety, reduces maintenance costs, and prevents long-term structural damage. Professional operators always follow recommended warming procedures before bringing a boiler to full operating condition safely. What is the first priority during a boiler emergency? Answer: the first priority during a boiler emergency is protecting human life and preventing further danger. Operators must immediately follow emergency shutdown, stop fuel supply, and activate alarms if necessary. If there is a risk of explosion, fire, steam leakage, or toxic gas release, the area should be evacuated quickly. After ensuring personnel safety, operators should assess pressure, temperature, and water level conditions carefully. Inspectors ask this question to evaluate emergency response knowledge and safety awareness, quick decision-making, proper communication, and following standard operating procedures are essential to minimize injuries, equipment damage, downtime, and operational losses during emergencies. Why is steam pressure controlled carefully in boilers? Answer: steam pressure must be controlled carefully because both high and low pressure create operational problems. Excessive pressure increases stress on boiler components and raises the risk of leaks, equipment failure, or explosion. On the other hand, low pressure affects steam supply and reduces production efficiency. Pressure control systems maintain stable operation by regulating fuel supply and steam generation. Inspectors ask this question to test understanding of boiler balance and control systems. Proper pressure management improves efficiency, protects equipment, and ensures safe plant operation. Operators should continuously monitor pressure gauges and control systems during boiler operation for stable performance. What causes repeated boiler tube failure? Answer: repeated boiler tube failure is usually caused by poor water treatment, overheating, corrosion, scale formation, thermal stress, or improper operation. Scale deposits reduce heat transfer and increase tube metal temperature, eventually weakening the tube material. Corrosion attacks the tube surface and reduces wall thickness. Over time, Sudden temperature changes also create thermal stress that damages the tubes. Inspectors ask this question to evaluate troubleshooting skills and maintenance knowledge. A good operator should identify the root cause instead of replacing tubes repeatedly without investigation. Proper water chemistry. Regular inspection, controlled operation, and preventive maintenance are necessary to reduce tube failure problems. Why is furnace purging necessary before boiler startup? Answer. Furnace purging is the process of removing unburned fuel gases from the furnace before ignition. Fresh air is circulated through the furnace using fans to clear any combustible mixture. If purging is skipped and ignition starts while fuel gas remains inside, a violent furnace explosion may occur. Inspectors ask this question because many boiler accidents happen due to improper startup procedures. Purging time depends on boiler design and safety standards. Proper purging ensures safe ignition, protects equipment, and prevents accidents. Every trained boiler operator must follow standard startup procedures carefully to maintain a safe working environment in the plant. Why should gauge glass be checked regularly? Answer. Gauge glass is used to indicate the actual water level inside the boiler drum. If the gauge glass becomes blocked, dirty, or damaged, it may show an incorrect reading. False water level indication is extremely dangerous because operators may think the water level is normal when the boiler is actually dry. This can lead to overheating and tube failure. Boiler inspectors ask this question to test practical operational awareness. Operators should regularly blow through and clean the gauge glass to ensure accurate readings. Maintaining a clear and functional gauge glass is a simple but very important part of boiler safety management. What happens if a safety valve does not operate properly? Answer. The safety valve is one of the most critical safety devices in a boiler. Its main function is to release excess steam pressure automatically when pressure exceeds safe operating limits. If the safety valve fails, pressure continues increasing inside the boiler shell. Excessive pressure can weaken the boiler structure and eventually cause a dangerous explosion. Inspectors frequently ask this question because operators must understand that safety valves protect both human life and equipment. Regular testing, calibration, and maintenance of safety valves are essential. A properly functioning safety valve prevents accidents, reduces operational risks, and ensures compliance with boiler safety regulations. Why is feed water treatment important in boilers? Answer. Feed water treatment is important because untreated water contains minerals, oxygen, and impurities that can damage the boiler internally. Hard water causes scale formation, while dissolved oxygen causes corrosion inside boiler tubes and drums. Both conditions reduce heat transfer efficiency and increase fuel consumption. Severe corrosion may also weaken metal surfaces and create leakage problems. Water treatment removes harmful substances before water enters the boiler system. Inspectors ask this question to check whether operators understand the relationship between water quality and boiler safety. Good water treatment improves steam quality, prevents maintenance problems, extends equipment life, and ensures efficient operation. Why is boiler blowdown necessary every day? Answer. Boiler blowdown is necessary to remove dissolved salts, sludge, mud, and impurities from boiler water. During steam generation, pure steam leaves the boiler while impurities remain inside. Over time, these impurities increase water concentration and create scale formation on boiler tubes. Scaling reduces heat transfer efficiency and causes overheating, fuel wastage, and tube damage. Daily blowdown helps maintain proper total dissolved solids (TDS) level and improves boiler efficiency. Inspectors often ask this question because many operators know the process but not the actual reason behind it. Proper blowdown practice increases boiler life and ensures safe, efficient operation. Why is flame failure dangerous in a boiler furnace? Answer. Flame failure becomes dangerous because fuel may continue entering the furnace without proper combustion. Unburned fuel accumulates inside the furnace and mixes with air, creating an explosive atmosphere. If ignition suddenly occurs, a furnace explosion can happen within seconds. That is why operators must immediately stop fuel supply whenever flame failure occurs. Modern boilers use flame scanners and safety interlocks to detect flame loss automatically. Boiler inspectors often ask this question to test emergency response knowledge. A trained operator must understand that quick action during flame failure can prevent major accidents, equipment damage, injuries, and costly production shutdowns. What is the most dangerous condition in a boiler? Answer. The most dangerous condition in a boiler is low water level. When water level drops below safe limits, boiler tubes become exposed to direct furnace heat. Without water cooling, metal temperature rises rapidly, weakening the tubes and causing them to burst. This may result in a deadly boiler explosion. Many operators focus only on pressure, but inspectors often check whether you understand the importance of maintaining proper water level. Regular monitoring of gauge glass, alarms, and low water cutoff devices is extremely important for safe operation and accident prevention in any steam boiler system.
Are you preparing for a boiler engineer interview? Then stop everything you're doing right now, because in the next 60 seconds, I'm going to show you the 80 most critical questions that interviewers ask, and that most candidates get wrong. In this video, we've compiled 80 real interview questions covering boiler operations, safety valves, steam pressure, maintenance procedures, IBR regulations, and everything a hiring manager wants to know. These questions come from actual interviews across Asia, Europe, and Africa. If this video helps you land your dream job, smash that like button. Subscribe for weekly engineering interview content.
Question. What is a boiler and what is its main function? Answer. A boiler is a closed vessel where water is converted into steam by applying heat. This steam is used as an energy source in various industrial processes, such as electricity generation, heating, or performing mechanical work. Its main function is to convert thermal energy into steam energy by burning fuel. Question. What is the difference between a fire tube boiler and a water tube boiler? Answer. Fire tube boiler. In this boiler, hot gases or smoke flow through the tube, heating the water outside the tube to produce steam. It is generally used for low pressure and low steam production. Example, Lancashire boiler, Cornish boiler. On the other hand, water tube boiler, water flow through the tube and hot gases or smoke are outside the tube, heating the water to produce steam. It is used for high pressure and high steam production and is more commonly used for in industry. Example, Babcock and Wilcox boiler. Question. What are the main components of a boiler? Answer. The main component of a boiler include furnace for burning fuel, drum for holding water and steam, tube for heat transfer, superheater for superheating steam, economizer for heating feed water, air preheater for heating combustion air, blow-down valve, safety valve, pressure gauge, water level indicator, etc. Question. What is the function of a boiler feed water pump? Answer. The function of the feed water pump is to supply the required amount of pure water to the boiler, which will be converted into steam. It pumps water at a pressure higher than the boiler operating pressure. Question. What is the importance of the boiler safety valve? Answer. The safety valve is an extremely important safety device for boiler. It automatically Release steam to reduce excessive pressure when the internal pressure of the boiler exceeds a certain limit, protecting the boiler from explosion. Question: briefly describe the boiler setup procedure. Answer: boiler setup is a caution process. Each step include inspecting the boiler, closing drain, filling feed water, opening air vents, checking the ignition system, starting the burner, monitoring pressure and temperature, and gradually increasing the load. Question: briefly describe the boiler shutdown procedure. Answer: the boiler shutdown procedure is an important as a startup. Each step include reducing load, stopping fuel supply, cooling down the boiler, opening drain, inspecting the boiler, and performing necessary maintenance. Question: why is it important to maintain the boiler water level? Answer: maintaining the correct boiler water level is crucial. If the water level is too low, the tube can overheat and rupture, leading to serious accident. Conversely, if the water level is too high, water can mix with the steam, priming or carryover will cause, which can damage turbine or other equipment. Question: what is boiler blowdown and why is it performed? Answer: blowdown is the process of draining a specific amount of water from the boiler drum. It helps control the concentration of dissolved solid like TDS and sludge inside the boiler, preventing scaling and corrosion, thereby increasing boiler efficiency and lifespan. Question: what is meant by boiler combustion control? Answer: combustion control refers to ensuring an efficient combustion process by maintaining the correct ratio of fuel and air in the boiler. Its goal is to maximize heat production and minimize pollutant emission. It is important for fuel saving and environment protection. Question: what are the main safety devices of a boiler? Answer: the main safety devices of a boiler include safety valve, water level indicator, pressure gauge, low water cutoff, high pressure cutoff, flame failure device, blowdown valve, manhole, and handhole. Question: what is the importance of boiler maintenance? Answer: regular boiler maintenance ensures safe and efficient operation, extends its lifespan, reduces unexpected breakdown, and lowers the operating cost. It helps prevent problems like scaling, corrosion, and fouling. Question: what specific point should be observed during boiler inspection? Answer: during boiler inspection, special attention should be paid to the condition of tube, drum, furnace, refractory, valve, gauges, pump, piping, and safety device. Looking for corrosion, crack, leaks, sealing, or slash. Question: what is boiler scaling and how does it affect boiler performance? Answer: scaling is the accumulation of hard mineral deposit on the internal surface of the boiler. It hinders heat transfer, leading to increased fuel consumption and a risk of tube overheating and rupture. Question: what are the ways to prevent boiler corrosion? Answer: boiler corrosion is prevented by feed water treatment like deaeration, chemical treatment, proper blowdown, pH control, and the use of oxygen scavenger. Question: what action would you take if the boiler has a low water level? Answer: low water level is an emergency. Immediate stop the fuel supply. Set the feed water pump if safe and allow the boiler to cool down. Identify and resolve the cause. Question: what action would you take if the boiler has high pressure? Answer: if high pressure occurs, the safety valve will operate automatically. If it does not, manually open the safety valve, reduce or stop the fuel supply, and try to increase the load. Identify and resolve the cause. What would you do if a boiler tube ruptures? Answer: if a tube ruptures, immediately shut down the boiler, drain steam and water, and prepare for repair. This is a serious emergency. Question: what are priming and carryover in a boiler? Answer: priming: water droplet escaping with steam from the boiler. This can be caused by rapid load changes, high water level, or water contamination. Carryover: solid particle escaping with steam. This can be caused by high TDS, high water level, or incorrect blowdown. Both can damage turbine and piping. Question: what action would you take if there is a flame failure in the boiler? Answer: if flame failure occurs, the burner will automatically shut down. If not, shut it down manually. Purge the furnace and identify and resolve the causes.
Question: what is boiler scale and how do you prevent it? Answer: boiler scale is a hard mineral deposit, calcium, magnesium, etc., that forms on the inner walls and tubes of a boiler. It reduces heat transfer efficiency and can cause serious damage to the boiler. Prevention methods include regularly testing water quality, using proper chemicals such as antiscalants, performing regular blowdown, and using a feed water softener system to remove hardness before water enters the boiler. Question: what are boiler mountings and what are their functions? Answer: boiler mountings are fittings and devices directly attached to the boiler for safe operation. The main mountings are: a water level indicator, shows the current water level inside the boiler. Pressure gauge measures steam pressure. Safety valve releases excess pressure automatically. A steam stop valve controls steam supply to the system. Feed check valve controls water entry into the boiler. Blowdown valve removes sludge and sediment from the bottom. Fusible plug melts at high temperature to prevent explosion by releasing pressure. Question: what is flue gas and why is it important to analyze it? Answer: flue gas is the exhaust gas that exits through the chimney after fuel combustion in the boiler. Typically contains CO2, CO, NOx, and SO2. Analyzing flue gas helps determine whether combustion is occurring efficiently. High levels of CO indicate incomplete combustion and fuel wastage. Proper flue gas analysis helps save fuel, improve boiler efficiency, reduce operating costs, and minimize environmental pollution. Question: why is boiler water treatment necessary and what chemicals are commonly used? Answer: if boiler water contains oxygen, chlorides, hardness minerals, or other contaminants, it can cause corrosion, scale buildup, and foaming, all of which reduce the boiler's lifespan and efficiency. Commonly used treatment chemicals include sodium sulfite or hydrazine, removes dissolved oxygen to prevent corrosion. Phosphate prevents scale formation on heat transfer surfaces. Anti-foaming agents prevents foaming and carryover. pH controllers, sodium hydroxide, maintains water pH between 8.5 and 10.5 to reduce corrosion risk. Question: what is the correct boiler shutdown procedure? Answer: the correct shutdown procedure is as follows. First, gradually reduce the fuel supply and turn off the burner. Then slowly reduce the steam load. Allow the boiler pressure and temperature to drop naturally. Never cool it down suddenly as this can cause thermal shock and structural damage. Maintain the water level at normal range throughout the process. Once pressure drops to zero, close all valves and record the shutdown in the logbook. Allow the boiler to cool completely before any inspection or maintenance work begins. Question: What are the causes of boiler explosion and how can it be prevented? Answer. The main causes of boiler explosion include dangerously low water levels, a faulty or stuck safety valve, excessive steam pressure buildup, corroded or weakened boiler shell, poor welding, and operation by untrained personnel. Prevention measures include performing regular inspections and maintenance, testing safety valves frequently, hiring only trained and certified operators, strictly following government safety regulations and standards, and ensuring that automatic low-water cutoff systems are functioning correctly at all times. Question. What are the daily checks a boiler operator must perform? Answer. A boiler operator should check water levels, steam pressure gauges, fuel supply lines, safety valves, feed water pumps, blowdown valves, and burner operation. Logs should be updated and any abnormalities reported immediately. Question. What is the purpose of a blowdown procedure and how often should it be done? Answer. Blowdown removes accumulated sludge, sediment, and dissolved solids from the boiler water to maintain water quality and prevent scale buildup. Surface blowdown is typically done once per shift, while bottom blowdown frequency depends on water test results and company policy, usually once or twice daily. Question. What actions do you take if boiler water level drops dangerously low? Answer. Never add cold water to an overheated boiler, as this can cause an explosion. The correct steps are to shut off the burner immediately, stop the fuel supply, alert your supervisor, and follow the emergency shutdown procedure. The boiler must be inspected before restarting. Question. What is the function of a safety relief valve? Answer. A safety relief valve automatically releases excess steam pressure when it exceeds the boiler's maximum allowable working pressure, MAWP. It is the last line of defense against a boiler explosion and must be tested regularly to ensure it opens and closes properly. Question. What causes a boiler to prime or carry over, and how do you fix it? Answer. Priming or carryover occurs when water droplets are carried into the steam lines, usually caused by high water levels, contaminated boiler water, sudden load changes, or excessive TDS, total dissolved solids. The fix involves reducing water level, performing blowdown, checking water chemistry, and adjusting steam output rate. Question. How do you ensure boiler efficiency and what are signs of poor efficiency? Answer. Efficiency is maintained through regular water treatment, keeping heat transfer surfaces clean, proper combustion air/fuel ratio adjustment, and minimizing heat losses through flue gas analysis. Signs of poor efficiency include high flue gas temperature, black or smoky exhaust, excessive fuel consumption, and scale buildup on tubes. Question. What is the difference between a fire tube boiler and a water tube boiler? Answer. A fire tube boiler is one where hot gas from combustion passes through tubes that are surrounded by water. It is simpler in design, easier to operate, and suitable for low to medium pressure applications. Examples include Lancashire boiler and Cochrane boiler. A water tube boiler, on the other hand, has water flowing inside the tubes while hot gases surround them from outside. It can handle much higher pressures and temperatures, produces steam faster, and is used in large industrial and power generation applications. Examples include Babcock and Wilcox boiler and Benson boiler. Question. What is cavitation in a boiler feed pump and how do you identify and fix it? Answer. Cavitation occurs when the pressure inside the feed pump drops below the vapor pressure of the water, causing small vapor bubbles to form and then violently collapse. This damages the pump impeller and reduces pump efficiency. Signs of cavitation include unusual rattling or crackling noise from the pump, vibration, fluctuating flow rate, and reduced pump performance. To fix it, you should check and maintain proper suction head. Ensure the feed water temperature is not too high, check for any blockages or air leaks in the suction line, and inspect the pump impeller for damage. Regular pump maintenance and proper system design help prevent cavitation from occurring. Question. What is the significance of pH level in boiler water and what happens if it goes out of range? Answer. The pH level of boiler water must be maintained between 8.5 and 10.5 for safe and efficient operation. If the pH drops below 8.5, the water becomes acidic, which causes severe corrosion of the boiler metal, tubes, and fittings, leading to leaks and structural failure. If the pH rises above 10.5, the water becomes too alkaline, which causes caustic embrittlement, foaming, and carryover of water into the steam lines. Operators must test pH levels regularly using test kits or online analyzers and adjust by adding appropriate chemicals such as sodium hydroxide to raise pH or acid dosing to lower it. Question: what is steam trapping and why are steam traps important in a boiler system? Answer: a steam trap is an automatic device that removes condensate, water formed when steam cools down, and non-condensable gases such as air from the steam system without allowing live steam to escape. Steam traps are extremely important because if condensate builds up in steam lines, it can cause water hammer, which is a sudden violent shock that can damage pipes, valves, and equipment. A failed open steam trap wastes energy by letting live steam escape, while a failed closed trap causes condensate flooding. Regular inspection and maintenance of steam traps is essential for energy efficiency and system safety. Question: what do you understand by the term working pressure and design pressure of a boiler? Answer: working pressure is the normal operating pressure at which the boiler runs during regular operation. It is always set below the maximum allowable working pressure, MAWP, to provide a safety margin. Design pressure, on the other hand, is the maximum pressure the boiler is engineered and built to withstand safely. It is always higher than the working pressure. For example, if a boiler has a design pressure of 150 psi, it may be operated at a working pressure of 120 psi. Operating a boiler beyond its design pressure is extremely dangerous and can lead to catastrophic failure. The safety valve is set to open before pressure reaches the design pressure limit. Question: how do you handle a boiler tube failure or leak during operation? Answer: a boiler tube failure is a serious emergency. Signs include a sudden drop in steam pressure, unusual hissing or whistling sound, drop in water level, and visible steam or water leaking from the boiler casing. The correct steps to handle this situation are to immediately reduce the load on the boiler, initiate a controlled shutdown by turning off the burner and fuel supply, alert the supervisor and maintenance team, and isolate the boiler from the steam header using the stop valve. Never attempt to repair a tube while the boiler is under pressure. Once the boiler is fully cooled down and depressurized, a qualified engineer should inspect and replace the damaged tube before the boiler is returned to service. Question: what is combustion and what are the essential requirements for perfect combustion in a boiler? Answer: combustion is a chemical reaction between fuel and oxygen that produces heat, light, carbon dioxide, and water vapor. For perfect or complete combustion to occur in a boiler, 3 essential elements must be present, which are commonly known as the fire triangle: fuel, oxygen, and heat. In practical boiler operation, perfect combustion requires the correct air-to-fuel ratio, sufficient mixing of air and fuel, adequate furnace temperature, and enough time for the fuel to burn completely. If there is too little air, incomplete combustion occurs, producing carbon monoxide, CO, and black smoke, which wastes fuel and is dangerous. If there is too much excess air, heat is lost through the flue gas, reducing efficiency. The ideal condition is called stoichiometric combustion, where fuel burns completely with the minimum amount of air required. Question: what is thermal shock in a boiler and how can it be prevented? Answer: thermal shock occurs when there is a sudden and extreme change in temperature in the boiler metal or components. This happens when cold water is suddenly introduced into a very hot boiler, or when a hot boiler is cooled down too rapidly during shutdown. The sudden temperature difference causes uneven expansion and contraction of the metal, which leads to cracks, warping, and structural damage to the boiler shell, tubes, and welds. To prevent thermal shock, always warm up the boiler slowly and gradually during startup. Never add cold feedwater suddenly to an overheated boiler. Always cool down the boiler slowly and naturally during shutdown, and maintain feedwater temperature as close to the boiler water temperature as possible. Preheating the feedwater using an economizer also helps reduce the risk of thermal shock significantly. Question: what is an economizer in a boiler system and what is its purpose? Answer: an economizer is a heat recovery device installed in the flue gas path of a boiler, typically between the boiler and the chimney. Its main purpose is to recover waste heat from the hot flue gases exiting the boiler and use that heat to preheat the incoming feed water before it enters the boiler drum. This reduces the amount of fuel needed to heat the feed water to the required temperature, which significantly improves overall boiler efficiency. A well-functioning economizer can improve boiler efficiency by 5 to 10%. It also reduces thermal shock by raising the feed water temperature before it enters the hot boiler. Regular cleaning of the economizer tubes is necessary to prevent soot buildup, which reduces its heat transfer effectiveness. Question: what is the difference between saturated steam and superheated steam, and where is each used? Answer: saturated steam is steam that exists at the boiling point corresponding to its pressure. It still contains some moisture and is in equilibrium with liquid water at the same temperature and pressure. Saturated steam is commonly used in heating systems, sterilization processes, food processing, and general industrial heating applications. Superheated steam, on the other hand, is steam that has been heated beyond its saturation temperature at a given pressure. It is completely dry, contains no moisture, and has a higher energy content. Superheated steam is used in steam turbines for power generation, in high-efficiency industrial processes, and in applications where moisture in steam would cause damage or inefficiency. As a boiler operator, it is important to know which type of steam your system produces, and to maintain the correct temperature and pressure for each application. Question: what is a boiler inspection, and what are the key things checked during an internal and external inspection? Answer: a boiler inspection is a thorough examination carried out by a qualified inspector or engineer to ensure the boiler is safe, structurally sound, and operating within acceptable limits. It is usually required by law at regular intervals. During an external inspection, the inspector checks the outer shell for corrosion, cracks, and leaks, examines all mountings and fittings such as safety valves and pressure gauges, checks insulation condition, reviews the operating logs and maintenance records, and observes the boiler during normal operation. During an internal inspection, the boiler must be completely shut down, cooled, and drained. The inspector then checks the inner surfaces for scale buildup, corrosion, pitting, cracks in welds and tubes, condition of the furnace, and integrity of the boiler drum. Question: what is the role of a boiler operator in energy conservation, and how can boiler efficiency be improved? Answer: a boiler operator plays a very important role in energy conservation because the boiler is one of the largest energy consumers in any industrial facility. There are several practical steps an operator can take to improve boiler efficiency. First, maintain the correct air-to-fuel ratio by regularly analyzing flue gas to ensure complete combustion with minimum excess air. Second, keep heat transfer surfaces clean by regularly removing soot and scale, which act as insulators and reduce heat transfer. Third, recover waste heat by ensuring the economizer and air preheater are functioning properly. Fourth, fix steam and condensate leaks immediately, as even small leaks can cause significant energy losses. Fifth, insulate all steam pipes, valves, and fittings properly to minimize heat loss. Question: what is a deaerator and why is it important in a boiler system? Answer: a deaerator is a mechanical device used to remove dissolved gases, primarily oxygen and carbon dioxide, from the boiler feed water before it enters the boiler. Dissolved oxygen is the most dangerous gas in boiler feed water because it causes severe pitting corrosion on the inner surfaces of the boiler, tubes, and pipework. Carbon dioxide dissolves in condensate to form carbonic acid, which also causes corrosion. The deaerator works by heating the feed water to its saturation temperature using steam, which drives out the dissolved gases. It also acts as a feed water storage tank and helps maintain a steady supply of hot feed water to the boiler. Question: what is carryover in a boiler and what are its causes and effects? Answer: carryover is the contamination of steam leaving the boiler with water droplets, dissolved solids, or other impurities. It is a serious problem because wet or contaminated steam causes damage to turbines, heat exchangers, and process equipment downstream. There are two types of carryover: mechanical carryover and vaporous carryover. Mechanical carryover occurs due to high water levels in the boiler drum, excessive steaming rates, sudden load changes, foaming caused by high total dissolved solids, TDS, oil contamination, or improper chemical treatment. Vaporous carryover occurs when certain dissolved chemicals vaporize and travel with the steam. Question: What is the purpose of a superheater in a boiler and how do you maintain it? Answer. A superheater is a heat exchanger component located in the boiler that heats saturated steam beyond its saturation temperature, converting it into superheated steam. The main purpose of a superheater is to increase the energy content and temperature of steam, improve thermal efficiency, and eliminate moisture from steam before it enters turbines or other equipment. Superheated steam improves the efficiency of steam turbines significantly and reduces erosion of turbine blades caused by wet steam. Question. What are the common causes of boiler corrosion and how can it be controlled? Answer. Boiler corrosion is the gradual deterioration of the boiler metal caused by chemical or electrochemical reactions with the surrounding environment. It is one of the most common and costly problems in boiler operation. The main causes of corrosion include dissolved oxygen in feedwater, low pH or acidic water conditions, carbon dioxide forming carbonic acid in condensate lines, high chloride content in boiler water, and caustic attack from excessively high alkalinity. Corrosion can occur on both the water side and the fire side of the boiler. Question. What is the function of an air preheater in a boiler system and how does it improve efficiency? Answer. An air preheater is a heat recovery device that uses the waste heat from flue gases to preheat the combustion air before it enters the burner or furnace. It is typically located in the flue gas path after the economizer and before the chimney. By preheating the combustion air, the air preheater reduces the amount of fuel needed to achieve complete combustion at the required temperature, which directly improves boiler efficiency. For every 20 degrees Celsius rise in combustion air temperature, boiler efficiency improves by approximately 1%. The air preheater also helps lower the flue gas exit temperature, which further reduces heat losses. Question. What safety precautions must be taken before entering a boiler for internal inspection or maintenance? Answer. Entering a boiler for internal inspection or maintenance is an extremely hazardous task and must be treated as a confined space entry. Before any person enters the boiler, a strict set of safety precautions must be followed without exception. First, the boiler must be completely shut down, isolated from all steam, water, and fuel sources, and all isolation valves must be locked and tagged out using a lockout-tagout (LOTO) procedure to prevent accidental startup. Second, the boiler must be fully cooled down to a safe temperature, usually below 40 degrees Celsius, and completely drained of all water. Third, all manholes and inspection doors must be opened and the boiler must be properly ventilated to ensure the atmosphere inside is safe, with sufficient oxygen levels and no toxic or flammable gases present. Question. What is water hammer in a boiler system? How does it occur? And how can it be prevented? Answer. Water hammer is a sudden, violent shock or banging noise that occurs in steam or water pipes when a moving fluid is suddenly forced to stop or change direction. In a boiler system, water hammer most commonly occurs when steam comes into contact with accumulated condensate in steam pipes, causing the steam to collapse suddenly and creating a powerful pressure wave. It can also occur when valves are opened or closed too quickly, when steam traps fail and allow condensate to flood the steam lines, or when cold feedwater is suddenly introduced into hot pipework. The effects of water hammer include severe mechanical shock to pipes, valves, fittings, and equipment, which can cause pipe joints to rupture, valves to crack, and support brackets to break. Question. What is the difference between a boiler gauge glass and a remote level indicator, and why are both important? Answer. A gauge glass is a direct reading water level indicator that is physically attached to the boiler drum and shows the actual water level inside the boiler through a transparent glass tube. It gives the operator an immediate and reliable visual indication of the water level without depending on any electrical or electronic systems. However, gauge glasses can become dirty, stained, or damaged over time, which may give false readings. A remote level indicator, on the other hand, uses electronic sensors or differential pressure transmitters to measure the water level and display it on a control panel that may be located away from the boiler itself. It allows operators to monitor water levels from a safe distance and can be connected to alarms and automatic controls. Both are important because they provide redundancy. If one fails or gives an incorrect reading, the other serves as a backup. Question. What is steam quality and how is it measured and maintained? Answer. Steam quality refers to the dryness fraction of steam, which is the proportion of pure dry steam relative to the total mixture of steam and water present. A steam quality of 1.0 means the steam is completely dry with no moisture, while a steam quality of 0.9 means the steam contains 10% moisture by mass. High-quality steam is essential for efficient operation of turbines, heat exchangers, and industrial processes because moisture in steam reduces heat transfer efficiency, causes erosion of equipment, leads to water hammer, and can contaminate products in food and pharmaceutical industries. Steam quality is measured using a throttling calorimeter or a separating calorimeter. Question: what is the purpose of a condenser in a steam system and how does it affect boiler operation? Answer: a condenser is a heat exchanger device used in steam power systems to convert exhaust steam from a turbine back into liquid water, condensate, by cooling it with cooling water or air. The main purpose of a condenser is to create a vacuum at the exhaust end of the turbine, which significantly increases the pressure differential across the turbine and improves its efficiency and power output. The condensate recovered from the condenser is then pumped back to the boiler as feed water, which is already hot and chemically treated, saving both energy and water treatment chemicals. Question: what are non-return valves and expansion joints in a boiler system and why are they necessary? Answer: a non-return valve, also known as a check valve, is a valve that allows fluid to flow in only one direction and automatically prevents backflow. In a boiler system, non-return valves are used on feed water lines to prevent hot boiler water from flowing back into the feed water pump or feed water tank when the pump stops. They are also used on steam lines to prevent steam from flowing back into the boiler from the steam distribution system when boiler pressure drops. Without non-return valves, dangerous backflow could damage pumps, cause water contamination, and create unsafe pressure conditions. Expansion joints are flexible connectors installed in pipework to absorb the thermal expansion and contraction of pipes as they heat up and cool down during boiler operation. Without expansion joints, the repeated expansion and contraction of pipes would cause enormous stress on pipe joints, supports, and connected equipment, eventually leading to fatigue cracks, leaks, and pipe failures. Question: what is the importance of maintaining a boiler logbook and what information should it contain? Answer: a boiler logbook is an official record of all activities, readings, and events related to the operation and maintenance of a boiler. Maintaining an accurate and up-to-date logbook is not only a legal requirement in most countries, but also an essential tool for safe and efficient boiler operation. The logbook serves as a historical record that helps operators and engineers identify trends, detect developing problems early, plan maintenance activities, and investigate the causes of incidents or failures. It also provides evidence of compliance with safety regulations during inspections. A comprehensive boiler logbook should contain daily operating data such as steam pressure, water level, feed water temperature, flue gas temperature, and fuel consumption readings taken at regular intervals. It should also include details of all maintenance work carried out, chemical treatment records and water test results, safety valve test records, blowdown records, details of any abnormal events or alarms. Question: what is the difference between sensible heat and latent heat, and how do these concepts apply to boiler operation? Answer: sensible heat is the heat energy that causes a change in temperature of a substance without changing its physical state. For example, when water is heated from 20 degrees Celsius to 100 degrees Celsius, the heat added during this process is sensible heat because you can sense or measure the temperature rise with a thermometer. Latent heat, on the other hand, is the heat energy absorbed or released by a substance during a change of state without any change in temperature. For example, when water at 100 degrees Celsius is converted into steam at 100 degrees Celsius, a large amount of heat is absorbed without any rise in temperature. This is called the latent heat of vaporization. Question: what is a boiler efficiency test and how is it carried out? Answer: a boiler efficiency test is a systematic procedure used to determine how effectively a boiler converts fuel energy into useful heat energy in the form of steam. Boiler efficiency is expressed as a percentage and represents the ratio of heat output to heat input. There are two main methods used to calculate boiler efficiency. The first is the direct method, also known as the input-output method. where efficiency is calculated by dividing the heat output of the steam produced by the heat input from the fuel consumed and multiplying by 100. This method is simple but requires accurate measurement of steam flow, fuel flow, and steam conditions. The second is the indirect method, also known as the heat loss method, where efficiency is calculated by identifying and measuring all the individual heat losses in the boiler such as dry flue gas losses, moisture losses, radiation and convection losses, and unburnt fuel losses, and subtracting the total losses from 100%. Question: what is the role of instrumentation and control systems in modern boiler operation? Answer: instrumentation and control systems play a vital role in modern boiler operation by continuously monitoring, measuring, and automatically controlling the various parameters that affect boiler performance and safety. Without proper instrumentation, operators would be unable to accurately know the current state of the boiler at any given moment, making safe operation impossible. The key instruments used in boiler operation include pressure gauges and pressure transmitters for monitoring steam and water pressure, temperature sensors and thermocouples for measuring steam, flue gas and feedwater temperatures, flow meters for measuring steam, fuel and feedwater flow rates, water level sensors and indicators for maintaining safe water levels in the boiler drum, and gas analyzers for monitoring flue gas composition to optimize combustion. Question: what is oxygen trim control in a boiler and why is it important? Answer: oxygen trim control is an automatic control system used in modern boilers to continuously monitor the oxygen content in the flue gas and automatically adjust the air-to-fuel ratio of the burner to maintain combustion at its most efficient level. It works by using an oxygen analyzer, also called a lambda probe or zirconia sensor, installed in the flue gas duct to continuously measure the percentage of residual oxygen in the flue gas leaving the boiler. The measured oxygen level is then compared to a set point value and the control system automatically adjusts the combustion air supply to keep the oxygen level at the optimum value, typically between 2 and 4% for most boiler fuels. If oxygen is too high, it means too much excess air is being supplied, which wastes energy by heating and expelling unnecessary air through the chimney. If oxygen is too low, it means insufficient air is being supplied, leading to incomplete combustion, carbon monoxide production, and soot formation. Question: what are the different types of boiler burners and what are the key factors to consider when operating them? Answer: boiler burners are devices that mix fuel and air in the correct proportions and ignite the mixture to produce a controlled flame for heating the boiler. There are several different types of burners used in boilers depending on the type of fuel used. Gas burners are used for natural gas or liquefied petroleum gas, LPG, and are generally the cleanest and easiest to control. They produce a blue flame and require careful management of gas pressure and air-to-gas ratio. Oil burners are used for heavy fuel oil, light fuel oil, or diesel and require the fuel to be atomized into fine droplets before combustion. Dual fuel burners can switch between gas and oil, providing flexibility and backup capability. Combination burners can burn gas and oil simultaneously in varying proportions. Pulverized coal burners grind coal into fine powder before combustion and are used in large power station boilers. Question: explain the working principle of a boiler. Answer: a boiler works by heating water to generate steam. The steam produced is used for various purposes such as heating, power generation, or industrial processes. This is achieved through combustion of fuel in the furnace, which transfers heat to the water to produce steam. Question: what are the types of boilers? Answer: boilers are generally classified into fire tube and water tube boilers. Fire tube boilers have hot gases passing through tubes submerged in water, while water tube boilers have water flowing through tubes that are heated by combustion gases outside the tubes. Question: what are the key components of a boiler? Answer: key components include the furnace, where combustion occurs, the boiler tubes, where heat exchange takes place, the economizer, which preheats feedwater, the steam drum, where steam is separated from water, and various safety valves and controls. Question: how is boiler efficiency measured and improved? Answer: boiler efficiency is typically measured by calculating the ratio of heat output compared to heat input. It can be improved through proper insulation, regular maintenance, optimizing combustion processes, and using advanced control systems. Question. What are the common boiler problems and how do you troubleshoot them? Answer. Common problems include scaling, corrosion, leaks, and inefficient combustion. Troubleshooting involves water treatment for scale prevention, corrosion-resistant materials, seal inspections, and adjusting air-to-fuel ratios for efficient combustion. Question. Describe the importance of boiler water treatment. Answer. Boiler water treatment prevents scale formation, corrosion, and fouling inside the boiler. It involves adding chemicals to the feed water to control pH levels, oxygen scavenging, and preventing mineral buildup, ensuring efficient operation and longevity of the boiler. Question. What safety measures are crucial for operating boilers? Answer. Safety measures include regular inspections, pressure relief valves, water level controls, combustion safeguards, and emergency shutdown procedures. Proper training of operators is also essential to ensure safe operation. Question. Discuss the factors affecting boiler efficiency. Answer. Factors include excess air levels, fuel type and quality, boiler load, ambient air temperature, insulation quality, and combustion control systems. Optimizing these factors helps improve overall efficiency and reduce operating costs. Question. How does modulation control improve boiler operation? Answer. Modulation control adjusts the boiler's firing rate to match changing heating demands, improving efficiency by avoiding frequent on-off cycling. It ensures the boiler operates closer to its optimal efficiency curve, reducing energy waste. Question. Explain the concept of boiler turn-down ratio. Answer. Boiler turn-down ratio refers to the ability of a boiler to reduce its maximum output to match lower demand levels. A higher turn-down ratio indicates better flexibility and efficiency in responding to varying load conditions without excessive energy consumption. Question. What are the main factors to consider when selecting a boiler for a specific application? Answer. Factors include required steam pressure and temperature, fuel type availability and cost, emissions regulations, space constraints, maintenance requirements, and initial investment costs. Question. Explain the role of combustion control in boiler operation. Answer. Combustion control ensures efficient fuel combustion by adjusting air-to-fuel ratios and maintaining proper flame stability. It optimizes fuel usage, reduces emissions, and prevents inefficient combustion that can lead to soot formation and heat loss. Question. What are the advantages and disadvantages of using natural gas versus oil as boiler fuel? Answer. Natural gas is cleaner burning, produces fewer emissions, and is often more readily available. However, it can be subject to price fluctuations. Oil, while less clean, offers more stable pricing and is commonly used where natural gas availability is limited. Question. Describe the significance of boiler insulation. Answer. Boiler insulation minimizes heat loss to the surroundings, improving energy efficiency and reducing operating costs. It also helps maintain stable operating temperatures, enhances safety by preventing surface burns, and prolongs equipment lifespan by reducing thermal stress. Question. What are the different types of boiler mountings and accessories? Answer. Boiler mountings include safety valves, water level indicators, pressure gauges, and blowdown valves, which are essential for safe and efficient operation. Accessories may include economizers, superheaters, and derators, enhancing boiler efficiency and performance. Question. Discuss the importance of proper boiler maintenance. Answer. Proper maintenance ensures reliable operation, extends equipment life, and prevents costly repairs. It includes regular inspections, cleaning of boiler tubes and surfaces, lubrication of moving parts, and testing safety devices and controls. Question. Explain the concept of boiler water level control and its significance. Answer. Boiler water level control maintains a consistent water level to ensure safe and efficient operation. It prevents overheating, steam quality issues, and damage to boiler components. Methods include float-operated devices, conductivity probes, and electronic controls. Question. What are the key differences between a steam boiler and a hot water boiler? Answer. A steam boiler generates steam for heating or power, while a hot water boiler circulates water for heating applications. Steam boilers operate at higher temperatures and pressures, while hot water boilers are generally lower in temperature and pressure. Question: how does water quality affect boiler operation? Answer: poor water quality can lead to scale formation, corrosion, and reduced heat transfer efficiency in boilers. Water treatment processes remove impurities and adjust chemical composition to prevent these issues, ensuring reliable and efficient boiler performance. Question: describe the process of boiler startup and shutdown. Answer: startup involves warming up the boiler gradually, purging air from the system, and ensuring proper water level and pressure before introducing fuel. Shutdown procedures include cooling down the boiler safely, draining water, and performing maintenance checks to prepare for restart. Question: what is the role of a boiler feedwater system, and why is it important? Answer: a boiler feedwater system supplies water to the boiler to replenish evaporated or consumed water. It is crucial as it ensures a continuous supply of water, regulates water quality, and prevents damage due to low water levels or poor water conditions. Question: explain the concept of boiler efficiency and thermal efficiency. How are they different? Answer: boiler efficiency measures how effectively a boiler converts fuel into usable energy, steam, or hot water. Thermal efficiency specifically refers to the energy output compared to energy input, considering losses due to radiation, convection, and incomplete combustion. Question: discuss the benefits and challenges of using biomass as boiler fuel. Answer: biomass offers renewable and potentially carbon-neutral fuel options, such as wood pellets or agricultural residues. Challenges include variability in fuel quality, ash management, and the need for specialized combustion systems. Question: what are the key considerations when retrofitting or upgrading a boiler system? Answer: considerations include assessing current system efficiency, compliance with updated regulations, integration with existing infrastructure, potential for energy savings, and evaluating return on investment, ROI, for new equipment or technology. Question: describe the process of boiler water treatment for preventing corrosion. Answer: boiler water treatment includes chemical additives to control pH levels, oxygen scavengers to reduce corrosion, and inhibitors to protect metal surfaces. Regular monitoring and adjustment of treatment levels are essential to maintain water quality. Question: what safety precautions should be taken during boiler maintenance or repair? Answer: safety precautions include locking out electrical controls, depressurizing the boiler, proper ventilation, wearing personal protective equipment, PPE, and following manufacturer guidelines and local regulations to prevent accidents or injuries. Question: explain the function of a boiler economizer and how it improves efficiency. Answer: a boiler economizer preheats feedwater using waste heat from flue gases before it enters the boiler. This reduces fuel consumption by recovering heat that would otherwise be lost through the flue, improving overall system efficiency. Question: what are the environmental considerations when operating boilers, and how can emissions be minimized? Answer: environmental considerations include reducing greenhouse gas emissions, CO2, NOx, particulate matter, and other pollutants. Strategies include using cleaner fuels, optimizing combustion processes, installing emissions control equipment, and regular maintenance. Question: discuss the concept of boiler turnkey projects and their advantages. Answer: boiler turnkey projects involve complete installation, commissioning, and operational readiness provided by a single contractor. Advantages include streamlined project management, reduced coordination efforts, quicker deployment, and comprehensive support services. Question: how does boiler sizing and capacity selection impact system performance? Answer: proper sizing ensures the boiler meets heating demands efficiently without excessive cycling or energy waste. Factors influencing sizing include building heat loss calculations, peak demand periods, system diversity, and future growth considerations. Single contractor. Advantages include streamlined project management, reduced coordination efforts, quicker deployment, and comprehensive support services. Question: explain the significance of boiler water chemistry and its impact on boiler operation. Answer: Boiler water chemistry affects corrosion, scale formation, and overall efficiency. Proper treatment controls pH, alkalinity, dissolved oxygen, and hardness levels to prevent damage to boiler components and ensure efficient heat transfer. Question: what are the different methods for improving boiler efficiency without modifying the boiler itself? Answer: methods include optimizing combustion air supply, improving insulation, implementing heat recovery systems like economizers or heat exchangers, enhancing boiler water treatment, and adopting advanced control systems for better operation. Question: discuss the role of controls and instrumentation in boiler operation. Answer: controls and instrumentation monitor and regulate boiler parameters such as water level, pressure, temperature, and fuel-air ratio. They ensure safe and efficient operation, optimize fuel consumption, and provide alarms for abnormal conditions. Question: what are the advantages and disadvantages of modular boiler systems? Answer: modular boilers offer flexibility in capacity adjustment, redundancy for reliability, and ease of installation. However, they may require higher initial investment, integration challenges, and dependency on multiple units for operation. Question: explain the concept of boiler efficiency testing and how it is performed. Answer: boiler efficiency testing involves measuring fuel input and steam or hot water output over a specified period to calculate thermal efficiency. Testing methods include direct and indirect methods, ensuring compliance with standards and optimizing performance. Question: describe the operation and benefits of a deaerator in boiler feedwater systems. Answer: a deaerator removes dissolved gases, such as oxygen and carbon dioxide, from feedwater to prevent corrosion and improve boiler efficiency. It preheats feedwater and reduces the need for chemical treatment, enhancing overall system reliability. Question: what are the safety considerations when installing or replacing boiler components? Answer: safety considerations include following manufacturer guidelines, ensuring proper clearances and support structures, handling heavy equipment safely, securing electrical connections, and conducting thorough inspections before operation. Question: discuss the impact of load cycling on boiler efficiency and maintenance. Answer: load cycling, frequent on-off operation, can reduce boiler efficiency, increase thermal stresses, and accelerate wear on components. Strategies to mitigate these effects include optimizing load profiles, reducing idle time, and using thermal storage systems. Question: explain the concept of boiler flue gas analysis and its importance. Answer: flue gas analysis measures combustion gases, CO2, O2, CO, NOx, to assess combustion efficiency, emissions levels, and compliance with environmental regulations. It guides adjustments in air-fuel ratios and combustion controls for optimal performance. Question: how does boiler control system integration with building management systems, BMS, improve overall building efficiency? Answer: integration allows centralized monitoring and control of boiler operations alongside other building systems, HVAC, lighting, optimizing energy use, coordinating maintenance schedules, and providing data for performance analysis and energy management. Question: what are the key differences between a fire tube boiler and a water tube boiler? Answer: fire tube boilers have hot gases flowing through tubes submerged in water, while water tube boilers have water flowing through tubes that are heated externally by combustion gases. Fire tube boilers are typically used for low-pressure applications, while water tube boilers are suitable for high-pressure applications. Question: explain the concept of boiler combustion efficiency and how it is calculated. Answer: boiler combustion efficiency measures how effectively the fuel is being burned to produce heat. It is calculated as the ratio of the heat output compared to the heat input from the fuel. Factors affecting combustion efficiency include excess air, fuel quality, and burner design. Question: discuss the importance of boiler blowdown and its types. Answer: boiler blowdown removes impurities and dissolved solids, such as salts, from the boiler water to prevent scaling and maintain water quality. Types include continuous blowdown, removes a small amount of water continuously, and intermittent blowdown, removes larger amounts periodically. Question: What are the factors to consider when selecting the material for boiler tubes? Answer. Factors include temperature and pressure conditions, corrosion resistance, mechanical properties, such as strength and ductility, weldability, availability, and cost. Common materials used for boiler tubes include carbon steel, stainless steel, and alloy steels. Question. Explain the concept of boiler efficiency modulation and its benefits. Answer. Boiler efficiency modulation adjusts the boiler's output to match varying heating demands, improving efficiency by reducing energy wastage during part load conditions. It optimizes fuel consumption, extends equipment life, and enhances overall system reliability. Question. What role does heat recovery play in boiler systems, and how is it implemented? Answer. Heat recovery systems capture waste heat from boiler exhaust gases or condensate and reuse it to preheat feedwater, air, or other process streams. This reduces fuel consumption, lowers operating costs, and improves overall energy efficiency of the boiler system. Question. Discuss the challenges and solutions related to boiler operation in cold climates. Answer. Challenges include freezing of water lines, reduced efficiency due to low ambient temperatures, and increased heating demand. Solutions involve proper insulation, heating of critical components, using antifreeze solutions in water lines, and adjusting boiler controls for cold weather conditions. Question. What are the key parameters monitored during boiler performance testing? Answer. Parameters include steam or hot water flow rates, fuel consumption rates, flue gas temperatures, combustion efficiency, emissions levels, such as CO, NOx, water levels, and pressure fluctuations. Testing verifies compliance with design specifications and regulatory standards. Question. Explain the concept of boiler turndown ratio and its significance in operation. Answer. Boiler turndown ratio indicates the range over which the boiler can modulate its firing rate. A higher turndown ratio provides flexibility to match varying heating demands, reduces cycling losses, and improves overall efficiency by operating closer to the boiler's optimal efficiency curve. Question. How can boiler performance be optimized through advanced control strategies? Answer. Advanced control strategies include implementing proportional integral derivative, PID, control loops, optimizing air-to-fuel ratios based on real-time combustion analysis, integrating predictive maintenance algorithms, and using adaptive control algorithms to respond to changing operating conditions.